All right, this is chapter 6.5. We're going to be solving exponential equations. So it's going to be a short lesson. Let's get started with the first part of the examples. So on here, when you're given with two exponential expressions and they're set at equal to each other, if they have the same basis or the same base, so for example, for the example number 1, you have the base of 9 on both expressions. You can just go ahead and compare the exponents. So x equals to 5 in this case. Okay, so in the perfect world, you're not gonna get the same basis on every question. So if you look at number 2, example number 2, you guys got a base 1, which is 9. Another one has a base of 27. So it's your job to make them the same base. Okay, so in this case, you're gonna write 9 as 3 squared, and you're gonna write 27 as 3 cubed. Okay, like the questions on the textbook, they're always gonna have you to um, they're gonna give you clues that you can somehow make the same base, and you just have to go look for it. Okay, so after I rewrite 9 as 3 squared, I cannot forget about the x in the exponent and then 2 in the exponent. We can still want to set it equal to each other. And then the next thing I want to do is to multiply the 2 and x, so that will be 2x equals to 3 times 2, that will be 6. The reason why I'm writing like that is because I already know that bases are the same, so I'm just comparing the exponents. So x equals to 3 in this case. Okay, let's go ahead and do some examples from the book. So on the textbook, you guys are gonna see you guys gonna be working on the odd numbers. I'm gonna be working on the even numbers. So number 4. So you wanna just compare the exponents because you have the same basis. So in this case, you can just go ahead and write x minus 4 equals to 8. Okay, so add 4 on both sides. X equals to 12. Okay, let's look at number 8. So you don't have the same base in this case. So you want to make sure that 243, you can write it in a base of 3. So 3 to the x power is equal to, you can use a factor tree for 243. That's 3 times 81, and then 81 is 9 times 9, and then 9 is 3 times 3. Okay, so which means that 243, you can rewrite that as 3 to the 5th power. In this case, you can just compare the exponents, so x equals to 5. Let's use a different color. If you look at number 10, 216, you can also use the factor tree. So 216 factor tree is going to be 6 times 36, and 36 is 6 times 6. So 216 you can write as 6 to the 3rd power to the x power equals to 6 to the x plus 10. Okay, if you multiply that, it's going to be 3x. You can just compare that to another exponent, set them equal to each other, x plus 10. Subtract x on both sides. It's going to be 2x equals to 10. X equals to divide by 2 on both sides, so x equals to 5. So the last one. Number 12. So 27 and 9, you can rewrite 27 as 3 cubed, as I mentioned earlier in the previous slide, example number 2. And then you can rewrite 9 as 3 squared. Okay, do not forget about the x minus 2. Okay, now you're just going to multiply, because right now I have the same basis, so you can just multiply the exponents. So it's 3x equals to the 3x, and then equal to 2 times x, that will be 2x. 2 times negative 2, that will be negative 4. Okay, So subtract 2x on both sides. Okay, this is a 2, my bad. So you have x equals to -4. Okay, so let's go ahead and do the next topic. So the next topic, um, this is what happened. You guys are going to get one of the two terms that's in fractions, like that. Okay, so it's your job to look for the common base. So how do you make the bases the same for both expressions? Okay, so now let's get started with this. First thing you want to do whenever you are receiving or when you see a fraction, you want to turn that into a non-fraction. So you know that 1/4 is going to be the reciprocal of 4. Okay, and then you want to write 4 to the -1, because every time when you guys have the -1 or negative exponents, that's going to be the reciprocal. Okay, so I'll rewrite 1/4 to 4 to the -1. Okay, to the x power, which equals to, now you know that the base is going to be 4. So how do you rewrite 16 in the basis of 4? So that's going to be 4 squared. Okay, so now you're going to multiply the exponents. So knowing that the bases are the same, all you need to do is comparing the exponents. So that's going to be -x equals to 2. Multiply by -1 on both sides, so x equals to -2. Okay, let's do this one more time. On example number 2, let's change the 1/32 to a non-fraction. So you're going to write 32 to the -1. Okay, and now how do you change the 32? How do you rewrite that in a base of 2? You want to make sure they're the same base, right? So make sure you can write 32 in a base of 2. So 32 is going to be 2 to the 5th power. Okay, but do not forget about that -1 out there. Okay, so now I have the same base. So if you have the same base, you can just go ahead and compare it. So this side is going to be 5 times -1, so it's going to be -5. And this side is going to be x plus 3. Okay, so go ahead and subtract 3 on both sides. X equals to -8. Okay, that's just basically how you're going to approach working on the next two problems. Okay, so number 14. So first thing I want to do is rewrite that 1/4 in a non-fraction form. So it's going to be 4 to the -1, okay, to the x power, which equals to 256. So 256, you can write that in factors of 4. So it'll be 4 times 64. 64 is 4 times 16, and 16 is 4 times 4, which means that 256 is 4 to the 4th power. Now you have the same bases, so you can just use the exponents and set them equal to each other. So it'll be -x equals to 4. Okay, so x equals to -4. All right, so use a different color for the next one. Number 18. So set that 1/27 into non-fraction. Rewrite that into non-fraction. That'll be 27 to the -1 power. So it'll be 4 minus x over here. And then 9 to the 2x minus 1. Okay, so this is what I'm going to do. I'm going to multiply the -1. I'm going to distribute the -1 to 4 -x. So that'll be 27. And then -4 plus x equals to 9, parentheses, 2x minus 1. Okay, what I'm going to do is I'm going to see what is the common base, so I can rewrite 27 and 9, and the answer is going to be 3. So what I'm going to do here is I'm going to erase 27 and I'm going to erase 9. I'm going to rewrite 27 as 3 cubed and rewrite 9 as 3 square. Okay, now I'm going to distribute the 3. Okay, and you know that the bases are the same now, so I can just set the exponents equal to each other. Okay, so 3 times -4, that's -12. 3 times positive x, that's 3x. 2 times 2x, that will be 4x. And 2 times -1, that will be -2. Okay, go ahead and solve it. I'm not gonna waste your time on this. Okay, you can just okay. Actually, I need to waste your time. So add 2 on both sides and subtract 3x on both sides. You should find that x equals to -10. Okay, so that's it for the lesson. And that's it for chapter 6.5. Stay safe, guys.